Hey guys, today's notes are on tectonic plate boundaries and movement that occurs at these boundaries. Before we go into today's notes, I want to show you a little bit about your Monday assignment. Your Monday assignment is in Edgenuity. You're going to notice that there's a new assignment, and that's the changing earth. All of this is one assignment. It's not the entire unit. It's just a lab, and that lab is on plate boundaries and movement. You will need to complete the warm-up, instruction, virtual lab, and the assignment on the lab and the summary, all on Monday. It is one lab that goes together. When you're doing the virtual lab, I have attached the student guide for you. The student guide has you to do a lot of drawings that's going to help you answer these questions. And you don't have to print out a paper at your house. Just use a piece of paper so you don't have to actually fill anything out in the student guide because the student guide is not going to be turned in to me. You'll get your grade from answering the questions, but you're definitely going to want to take some notes during the lab so that you have those to use. So that's on Monday of this week. So let's go over the notes so that you know how to do the lab on Monday. So on Wednesday, we talked about how the lithosphere, which is the crust and the upper portion of the mantle together, is divided into these large tectonic plates. And these red lines on the map, these are the boundaries of where different tectonic plates meet. So we've got tectonic plates, and they move. Okay, so sometimes the plates are pulling apart from one another, sometimes they're pushing together, and sometimes they slide past. And so we're going to look at what happens at all of these different boundaries. So the first one that we're going to look at is a divergent boundary. Divergent sounds like the word divide in math, and it means to pull apart or to separate. So if you ordered a pizza and you were going to divide it between 3 people, you would be pulling apart the pizza and separating it into those 3 different people. That's no different with tectonic plates that are divergent. They are dividing or pulling apart. When these plates pull apart, we have a lot of earthquake activity because rock is breaking. We have volcanic activity because this magma, as the 2 plates separate, we have magma that begins to rise and fill in. We get new landforms. We can see new land is created in this area as they are pulling apart. So we're going to look at a map several times in this unit, and this map is color-coded for you. I've made a key down here, and so these are the divergent boundaries, and I've marked them all in yellow on your map. So you can see in the middle of the Atlantic Ocean here that the tectonic plates are pulling apart. The North American plate is pulling away from the Eurasian plate and the African plate. So through the entire middle of the Atlantic Ocean, it is actually growing as those plates pull apart and new ocean floor is being created. Some plates are not pulling apart, but rather they are colliding with one another or coming together. The word for that is a convergent boundary. Convergent means to come together or to push together. And so there are 3 subcategories of convergent boundaries. Oceanic, where 2 oceanic plates come together. Oceanic continental, where an oceanic and continental crust come together. And continental, where you have 2 continental crusts coming together. In all of the convergent boundaries, they have this one vocabulary word in common, and that word is subduction. Subduction means that one of those 2 plates is going to sink under the other one. So we have this oceanic plate ducking under the oceanic plate. This oceanic plate is subducting under this continental plate. This continental plate is subducting under this one. So let's look at each of these individually. We'll start with continental. When you have 2 continental plates which have similar densities and thicknesses that are coming together, one will still subduct under the other, but we have a lot of mountains that are formed. Actually, some of the tallest mountain ranges in the world are created this way. So I want us to look at that on our map as well. Okay, so right here we have India, and we have Asia, and we have the Himalayan mountains. Here's our purple convergent boundary. So we have continental crushing into continental, and as they converge, we have the mountain formation that we see. Another example that we could have of convergent boundaries are oceanic and continental. We still have one that is subducting under the other. We still have, as this goes under, we're going to have excessive heat and pressure. So we end up with some magma pockets. It's very common to have volcanic activity. We're still going to have mountain range formation as those two are pushing into one another and buckling up. But we get a new feature that we didn't have with continental, and that's this deep ocean trench here. As the oceanic crust is subducting underneath the continental, water is going to flow into that area or crack as well, making some of the deepest places on the ocean floor. The third type of convergent boundary is oceanic-oceanic. So with oceanic-oceanic, we have our two oceanic tectonic plates that are coming together. One is still subducting under the other. We still have melted material. We're not going to see a mountain range like we would on a continent because it's covered by the ocean floor. But we do end up with mountains again, this time in the form of we see an island arc. So the volcanic activity that's happening will eventually grow tall enough to stick out of the ocean and create an island. So let's look at those on the map as well. We've looked at when we have continental convergent. But here in South America, where we have the Andes Mountains, we have continental and oceanic conversion. We would also have a deep sea trench here. And in the Pacific Ocean, all through here, where we have numerous island chains, we have oceanic and oceanic coming together to create these island arcs that we see as well. The third type of boundary is a transform boundary. So convergent means to come together, divergent means to pull apart, and transform means to slide past each other in opposite directions. Your book showed you pictures and talked quite a bit about how a river would change its flow rate. Mine shows you a road. So as one plate moves one direction and one plate moves the other direction, a lot of tension builds up, and we often have a lot of earthquake activity in this area. So let's review these three again. We have all of these are the subtypes of convergent, continental and oceanic coming together, oceanic and oceanic coming together, continental and continental coming together. When two plates pull apart, we have a divergent boundary, and as that pulls apart, we get new crust that's being created. Oh, I'm sorry. And the third one here is our transform boundary, where they're moving past each other in opposite horizontal directions. So let's go back to, let's go back to our map again, okay? And we have our transform boundaries that are on here as well, okay? Moving in opposite horizontal directions. Next week, we're going to be looking at different types of mountains and how these boundaries help in the creation of those. So this is going to be helpful with that. But I do want to point out to you that not all earthquake and volcanic activity happens on tectonic plate boundaries. The majority of earthquakes and the majority of volcanic activity does happen on these boundaries, but we also have other places where we can have volcanic activity and earthquake activity. So specifically where we live, I want to talk a little bit about a fault line. So in the United States, we live here. Okay, so let's go back and look at that on the whole map. We're about right here. Not on a tectonic plate boundary at all. We're in the middle of a tectonic plate. However, we do happen to fall on what's known as a fault line. A fault is just a large crack or fracture in the rock where movement occurs. Excuse me. So if you notice this map from the United States Geological Survey, the USGS, this is showing you hot zones for potential earthquakes in the United States. So where we live happens to be in the highest color area because we live on a fault line, not on a tectonic plate boundary. The name of our fault line is the New Madrid Fault. There are also, you'll notice California has a tremendous amount. It's in the high hazard area. It lies on a fault line called the San Andreas Fault, but it also has multiple tectonic plate boundaries in that region as well. You'll notice Hawaii is falling into that same category, as well as parts of Alaska. So I want to share a website with you. If in your resources in Google Classroom, you go to your slideshow, and on this particular slide, which is slide 26, the USGS earthquake website, if you click the present button, it will take you, and then click on the picture, it will take you to this website. And let me move my screen a little bit because you can't quite see it all. Okay. On this website, you are able to see earthquakes that are occurring in real time around the world. So if you go to the gear, it'll let you change, and I'm going to have it on earthquakes within the last week. And I'm going to go and I'm going to change it to the United States. And so all of the earthquakes that are shown here have happened within the last week in the United States. So I'm going to zoom in to where we live, and I'm going to show you the earthquake activity along the New Madrid fault line. So you can see in the last week in our area, here's Paducah, here's Memphis, Nashville, St. Louis, we live here. In the last week, there have been 4 earthquakes. So there's a lot of information where you can play around with it. You can click on it and see where an earthquake took place and what the magnitude was on the Richter scale. The smaller the dot, the smaller the earthquake. But I also want us to zoom out, and I want us to look at the whole world. When we look at the whole world on this map, I want you to notice that most of the earthquake activity is happening along those tectonic plate boundaries that we just looked at. Not all of it, but the vast majority does occur where we have the tectonic plate movement occurring. Okay, that finishes up our notes for today. You do have an assignment to write 2 sentences that you have learned from today's notes and or the book. That is going to join the 3 sentences you wrote earlier in this week, and it needs to go in your science folder until you come to class next week for those of you that are in person. For virtual students, I will give you the directions for what to do with that next week as well. So when you are finished with that, you are done for this week, and if you have any questions, please let me know.